Hey everyone, welcome to GeoMind. In this video, we are going to continue our geotectonics lecture. So in the previous lecture, we discussed about lithosphere and asthenosphere. In today's video, we are going to discuss about the plate boundaries, and the plate boundaries that we are going to talk about is divergent plate boundary. Okay. Uh, in the previous lecture, we discussed about lithosphere and asthenosphere. So hopefully you have an idea what is lithosphere and what is asthenosphere. And basically your plates are made up of your tectonic plates are made up of lithosphere. Okay, and they basically float over this weaker layer which is known as asthenosphere. All right, so today we are going to discuss about divergent plate boundaries, basically those plate boundaries or those plate junctions where two plates are moving away from each other in the opposite direction, and we will discuss the landforms which are created with this geotectonic phenomena. All right, so you can see that in this image there are two plates, North American plate and this one is Eurasian plate. Eurasian plate, these are major tectonic plates. Okay, so if you look at this map, you can see this North American plate is here, right, and this is Eurasian plate. Okay, so the image we are discussing is somewhere around here in the map, which is basically the mid-Atlantic region, right? This region, which is basically the S-shaped Atlantic Ocean, and exactly in between there is a feature which is known as Mid-Atlantic Ridge. Mid-Atlantic Ridge, and this is a landform which is created due to the divergence of North American plate and Eurasian plate, which are basically moving apart from each other in the opposite direction. So you can see the arrows which are pointing in opposite direction, right? And this is basically the Mid-Atlantic Ridge. What is this basically? Ridge basically mean mountain chain, right? So this is basically an underwater mountain chain which is being created due to the fact that North American plate and Eurasian plate are moving apart from each other. And this underwater mountain chain or submarine mountain chain is also known as mid-oceanic ridge. Okay, so we also call it as MOR in short form, mid-oceanic ridge, and the specific name of this region is Mid-Atlantic ridge, which is basically a type of mid-oceanic ridge. Okay, so this is a type of landform which is created when two plates are moving apart from each other, right? So the content of this lecture, we will discuss about divergent plate boundaries. Hopefully you have an idea that what is divergent plate boundary, and then we'll discuss about deeply about mid-oceanic ridges and fast and slow oceanic ridges, continental rifting and type of continental rifts, right? So here you can see we have already discussed about all three in brief in the previous lecture, and we will be focusing on this region here, this boundary here, which is divergent plate boundary. Okay, this is also known as constructive plate boundary. Constructive, why it is called constructive? Because new lithosphere is created here. Okay, the two plates are moving apart, the magma is reaching towards the surface, it is solidifying, and the new ocean floor is being created, okay, in this region, right? So here is a map of the world where you can see the different types of plate boundaries. Okay, you can see the red line, blue line, green line, right? So the mid-oceanic ridge is represented by the red boundaries. Okay, so wherever you can see the red lines, red boundaries, those are basically your divergent plate boundary, where the lithosphere is moving apart over the asthenosphere. Okay, and this region is also known as spreading center. Okay, and in the spreading center your landform is created mid-oceanic ridge if it is in the oceanic region, and rifting happens if it is in the continental region. Okay, so we will also discuss about a ridge. All right, so let's say this is your African plate and this is the Africa, right? This is the Africa, and here you can see this portion is also red, but it is in the region of continental plate, right? So this is a rift. Rift basically forms when there is a continental plate or continental region, and in that region when the two plates are moving apart, while the ridge, mid-Atlantic ridge or the mid-oceanic ridges form in the oceanic portion. Okay, so here you can see the entire Atlantic Ocean is there, and in between there is a ridge, right? So mid-oceanic ridge forms in the oceanic region. All right, so here you can see the mid-Atlantic ridge is very large feature, almost running entire planet, right? While in the blue region you can see you have convergent plate boundary. This we will discuss in the next lecture. Okay, so here you can see the plate boundaries in action through a spherical model of the Earth. Okay, so this is just to show you that how plate moves, okay, in which direction they are moving, right? One more thing is that plate boundaries were basically first established by plotting the location of the earthquakes, volcanoes and transform faults. So when we plotted the earthquakes, volcanoes and transform faults, then only we knew about the plate boundaries. Okay, so this is a very important point. And you can see that these red dots represent the earthquakes. And most of the earthquakes are happening in the boundaries region. You can see this is the ring of fire where convergent boundary is there. Okay, and this is the mid-Atlantic ridge. Okay, in mid-Atlantic ridge there are no or mid-oceanic ridge there are no major earthquakes. Okay, major earthquakes happen in the convergent region, like in the Andes, where the Nazca plate is subducting beneath the Pacific plate, right? And in the convergent region you can see you have very vast amount of earthquakes, while in the divergent region there are earthquakes but there are very shallow earthquakes. So why it happens, why convergent boundaries have high number of earthquakes, very major earthquakes, while the divergent boundaries do not have that severe severity of the earthquakes? This we will discuss in the upcoming lectures. Okay, so this is just to know that earthquakes, volcanoes and transform faults, they are basically happening due to the plate boundaries. Okay, so divergent plate boundary, these points are important, you can write them down. Okay, plates move apart from each other in the opposite direction. This is very important. Okay, forming mid-oceanic ridges and continental rift zone. Again I said mid-oceanic ridges, नाम से पता चल रहा है कि it is happening in the, it is forming in the oceanic region. If there is oceanic region, so lithosphere will be a type of oceanic lithosphere. Okay, made up of basalt. It is thinner than continental lithosphere. Okay, and also heavier or denser. Okay, while the continental rift zone, like the East African rift, is happening in the continental region. Okay, also known as constructive plate boundary or spreading center. Now let's talk about that how many type of plate boundaries are there in the divergent plate boundary. So there are two main types: oceanic plate separation and continental plate separation. Okay, Oceanic plate separation will form mid-oceanic ridge. Continental plate separation will form continental rift zone. So let's look at them one by one through the diagram. Okay. So here is your oceanic plate separation. Okay. So if you look at this diagram, you can see that this boundary, this is your part of Atlantic Ocean, right? So wherever the ocean is there, this lithosphere is thinner, right? This portion, thin oceanic lithosphere, right? It is thin, but remember it is denser or heavier. Okay, while the continental region have more thickness to it, right? So this region is continental lithosphere. Okay, wherever the continents are there, the lithosphere will be thicker but lighter. Okay, this you have to remember. Okay, now let's talk about mid-oceanic ridges. Okay, so majority of the divergent plate boundaries are associated with mid-oceanic ridges. Okay, they are basically having high heat flow and volcanism. Obviously, if the plates are moving apart, this region will get thinner, right? And if this region is thinner, the magma from the inside, okay, it will rise up wherever there is a weak zone. Okay, so this is basically the spreading center, and through this spreading center the magma will reach the oceanic surface or the continental surface and form a new oceanic floor. Okay, so this you have to remember. Now, the global oceanic ridge system is the longest topographic feature in the Earth's surface. Okay, very factual question. It is almost 70,000 kilometers in length. Okay, so this question can be asked in your examination, be it CSIR, GATE, or UPSC. Okay, and along the axis of MOR, new oceanic lithosphere is formed. Okay, so new lithosphere is how it is forming. Magma is coming out, and magma is then solidifying, okay, as a lava. Okay, and new ocean floor is being created through the solidifying of the lava itself. Okay, now MOR are bounded by normal faults and characterized by shallow focus earthquakes limited to axial rift zone. इसका मतलब क्या है? Right. So this mid-oceanic ridge are basically bounded by normal faults. Normal faults are like this, right? Okay, so like this is your mid-oceanic ridge, something like this it happens. Okay, lava is creating these mountain chains, and the boundary is of normal faults. Okay, so they are basically bounded by these normal faults. We will look at the image and then you will be able to imagine this more easily. Okay, and remember the earthquakes that I discussed. Okay, why there are no major earthquakes? Because the earthquakes are characterized by shallow focus earthquake. Shallow focus means that the earthquake has less than like 10 to 20 kilometers depth of focus. Okay, and it is limited to axial rift zone. Axial rift zone means that if this is the region of the rifting, wherever the middle axis is there, only in this region you will find the earthquakes, not in this region or this region. Okay, on the axis of the mid-oceanic ridge. Okay, generally the height of the ridge is 2 to 3 kilometers. Okay, and width can be 1000 to 4000 kilometers. So it is pretty wide, but it is also longer. Okay, 70,000 kilometers is very large length, but its height is limited to 2 to 3 kilometers. Okay, Along the axis crest of some MOR, the Rift Valley, the axis is offset by transform faults. Okay, so here you can see this is the enlarged portion of a mid-oceanic ridge. So this region is the mountain chain. Okay, this region is the mountain chain, and they are offset. Offset means this part. They are offset by transform fault. Okay, here you will have transform fault. Okay, so if this is the axis of the mid-oceanic ridge, then this will be your transform fault, this yellow line. Why it happens? It happens due to the geometry of the earth. Okay, mid-oceanic ridge is not a continuous single line like this. Okay, these are the mountains. It is not continuous single line. Due to the spherical nature of the earth, the mid-oceanic ridge is like this in zigzag patterns. Okay, so these offsets are basically your transform faults. Okay, and why it happens? It happens due to the spherical nature of the earth. Okay, due to the geometry of the earth, the line is not straight, rather it is offset by the transform faults. Okay, so why MOR axis is offset by the transform fault? It is because of the geometry of the earth. Okay, तो बेसिकली ये आपकी मिड ओशनिक रिज है, फिर यहाँ पे थोड़ा सा ऑफसेट हो जाता है, ये आपका ट्रांसफॉर्म फॉल्ट हो जाता है, फिर यहाँ से दोबारा से मिड ओशनिक रिज शुरू हो जाती है. तो it is not like continuous line, rather it is in zigzag pattern. Okay, and bounded by transform fault. Okay, okay, so sea floor spreading on the surface of the sphere cannot follow a smoothly curving line. A smoothly curving line cannot be there due to the spherical nature of the earth. So that's why it is offset by transform faults. Okay, now mid-oceanic ridges are of two types: fast and slow spreading ridges. Fast spreading ridge means that the spreading rate is more than 6 centimeter per year. Okay, so if the plates are moving more than 6 centimeter per year, or if the space in between is created, okay, like this is plate number 1, this is plate number 2, they are spreading apart, and the new space is created which is having the width 6 centimeter or more per year, then the spreading rate is said to be high. Okay, so East Pacific rise is basically a type of mid-oceanic ridge, but it's a fast mid-oceanic ridge. Okay, East Pacific rise, this name you have to remember. So what are the feature of the fast spreading ridge? The feature is that fast spreading ridge is gently sloping. Okay, gently sloping, it means that it does not have very high altitude, okay, in the bathymetry, rather it has gently sloping profile like this. Okay, why it happens? Because fast spreading ridge do not have enough time to create these highly elevated mountain range, rather they become this like shield type of volcanoes. Okay, so the ridge is not sharp, rather it is smooth or gentle. Okay, so East Pacific rise between Pacific and Nazca plate has fastest spreading rate of 16.5 centimeter per year. Okay, so this point you have to remember. The bathymetry is smooth. Okay, because more buoyant hot rock is there and it does not have enough time to cool because of the fast spreading rate, and that's why the bathymetry is smooth. Bathymetry is why it's called bathymetry. Whatever the topographic features are there in the submarine region, these are known as bathymetry. Okay, so if any landform is there which is above the sea level, then we call it as topography, and whatever the landform that is present below the ocean, that is known as bathymetry. Okay, Mohorovičić discontinuity is a sharp tectonic boundary. Okay, Mohorovičić discontinuity, the discontinuity between crust and mantle, right? Earthquakes release less energy. Okay, these point you have to remember. Fast spreading ridges are dominated by volcanism because of the high amount of magma that is being released. Okay, so example is East Pacific rise. Okay, and because it is gently sloping, it does not have any rift valley in between. Remember that mid-oceanic ridges is not like a single, like it is not like this, like a single mountain. Rather, it has in between a valley. So outside there are mountains, ridges, and in between there is a valley where the lava is being, erupted apart like this. In fast spreading ridges, there is not very prominent valley in between. Okay, so it is like this, something like this. Okay, so here you can see in between there is no valley. So if you look at the profile of fast spreading ridge and slow spreading ridge, fast and slow, you can see fast spreading ridge is like gently sloping, right? While slow spreading ridges has mountains, ridges on the outside. In between there is a valley, rift valley. Okay. Okay, so this is the magma chamber which is beneath the fast spreading ridge, pretty big. Okay, and in the slow spreading ridge, the in between there is a rift valley, and these are basically the ridges which are, and these you can see are bounded by normal faults. Okay, while the offset is transform fault. Okay, then there are slow spreading ridges. So slow spreading ridges are those which have spreading rate less than 6 centimeter per year. Okay, bathymetry kya hai? Tall, steep and rugged mountain chains are there. All right. Like for example, mid-Atlantic ridge, which is a very prominent mid-oceanic ridge, has a spreading rate of 2.5 centimeter per year. Okay, it means that new ocean floor which is created has width of 2.5 centimeter in a year. Okay, and then there are also called ultra slow spreading ridges, which are basically having spreading rate less than 2 centimeter per year. Example is Geckel Ridge and Southwest Indian Ridge. Okay, axial rift valley is prominent in the slow spreading ridge. Okay, so here you can see the ridges. In between you can see this is the axial valley. तो यहाँ पे valley आपको पूरा पूरा दिख रहा होगा. Okay, and mountain is tall and rugged. Okay, here is the fact: Iceland is the only place where mid-oceanic ridges and hotspot occur together. Okay, तो आइसलैंड बिल्कुल बीच में जा रहा है मिड अटलांटिक रिज के, लेकिन साथ साथ यहाँ पे हॉटस्पॉट भी आपका है. ओके, okay, so this is it for mid-oceanic ridges. In next we will discuss about convergent plate boundaries. Okay, so hopefully in this lecture you have got some important points for your exams. Okay, till then stay safe and goodbye. If you like the lecture, do comment down below your thoughts and share this video as much as possible. Thank you.